Awesome. Thank you, everyone. So, hi again. Welcome. I am Anushka Mittal, and I work with ChainGuard as a software engineer there. I have been a contributor to Kyverno for quite some time. I think almost 4 years now. I am a maintainer to one of its projects, and today we have a really cool panel in front of you, and we're going to talk about all things Kyverno. So, Kyverno, of course, I'll let everyone introduce themselves, as and when we take the mic. So, that was for me. Kyverno is a Kubernetes native policy engine. But let's stop right there and understand what a policy engine is first, right? So, a policy engine, to understand very easily, is kind of like a traffic cop. A traffic cop would sort of make sure there are some, traffic rules and regulations and people follow it. And they'll make sure there are no wrong entries, no people not wearing seat belts, people are, abiding by rules. So similarly, a policy engine will play the same role for your workloads, for your clusters. A policy engine will make sure whatever rules you've, defined in the beginning, your workload complies with it. A policy engine will sit on top of your workload, make sure nothing wrong goes in, make sure everything is as you would expect it. No surprises, no heart attacks all of a sudden. So that's a policy engine. And now what is Kyverno, right? So Kyverno, like I said, is a Kubernetes native policy engine. It is a CNCF incubating project which offers you multiple capabilities. It lets you handle validation, dynamic validation, so it makes sure that whatever is going inside your cluster is abiding by rules that you've set. So if you don't want something with a label XYZ, that resource does not go inside your workload. Apart from validation, it also offers you mutation, generation. It will help you clean up your workloads and also verify images that are already inside or that are going inside your clusters. Now, that's really cool, and that's actually one of the reasons why you would want to use Kyverno. So that's our next slide. Why would you want to use Kyverno? Now, anyone familiar with Kubernetes will know what a deployment YAML looks like, right? Because Kyverno is Kubernetes native, your policies that you're supposed to write and make sure they're present in your cluster, they look very similar to your regular YAMLs. So it's very easy to use, it's very easy to understand and get started with. Kyverno offers a Kyverno CLI as well. How that helps you is by letting you test your policies before you put them in your cluster, test them to make sure it passes for all of your edge cases and for all resources that you would expect. Kyverno also offers auditing and reporting capabilities. That means in your cluster, it would help you generate a report to make sure you know what's happening, analyze your cluster, and be able to understand how your cluster is doing. Kyverno has a very active community, which is always in conversation about how to make things better, how to make things bigger. It's a project with 5.k, I think a little more than 5.k GitHub stars. And there's a huge built-in policy set, which covers the standard use cases, of course, but also more than that. Now, the last reason, which we'll cover a little later in the session, is Kyverno is expanding beyond Kubernetes. And that means it's looking to help you ensure compliance, security, look at governance, be a policy engine in not just Kubernetes, but beyond that. With that, I'll let Sachin take over the features.
Hello, everyone. My name is Sachin Agarwal, and I'm working as a solutions architect at Nirmata. So, since you have seen like why we use Kyverno and how we can use Kyverno and where are the use cases that we can use Kyverno, let's go and try to go deeper into the concept and see how a novice Kyverno user can author a policy, right? But before that, let's first see what the structure of a policy looks like, right? So as you can see here, right, a policy contains multiple rules, right? And inside each rule, there are two subsections where one of the section tells you about what are the resources with which it has to match, right? So it has a match and exclude section which defines which resources you want to apply this policy to, or what are the resources which you want to exclude from the policy execution, right? Whereas on the other section, we have the type of policy like validate, mutate, generate, verify images. So these type of policies actually contains the condition also, like what are the conditions which you want to match, and then based on that take an action, right? So here is a sample policy which actually takes care of all those structure. Uh, yeah. So you can see that in this spec, there is a validation failure action which can be either enforce or audit. So in case of audit, it will just report your policy violation, whereas in case of enforce, it will block the request at the admission itself, right? And then there is a background flag which will take care of the background scans, right? And as you can see, there are rules which define the match and exclude condition and the validate condition. So now so we have prepared a small demo. Let's go and see everything in action, right? So what I've done is a small cluster running on my local, right? And I have Kyverno deployed on it. So if I just do policies, currently there is no policy, right? And let's first understand what happens if there is no policy in your system, right? And what all harms can actually happen with your cluster. So what I'm going to do is I'm just going to run one simple pod, right? Which is using image, a demo image, and then what it is essentially doing is it is mounting a proc hyphen 1 hyphen ns mount volume, right? And then it's doing something. So let's go and execute this command, right? So you can see here there is a security context saying that privilege true, right? So what it can actually do is it is mounting to the root volume of your node, right? And then if I just do ls proc, right, you can list down all these processes that are running there, right? And you can even tamper with the init process, right, which can bring down your whole system, right? So how you can actually mitigate all these problems, and how you can block such kind of pods into your system, right? Because this is very harmful, right? So now let's do one thing. Let me deploy one policy which actually doesn't allow these kind of pods to go in, right? So we have a policy called privilege escalations policy. So what it will do is it will not allow any pod to go inside Kubernetes which has allow privilege escalation as true, right? So it is checking for this particular configuration in your manifest, saying that allow privilege escalation should be false, right? Let's go ahead and apply this policy, right? And let's see whether this policy is there. So you can see that policy is there, right? Now again, let's go and deploy the same pod that I was trying to deploy, right? So if I hit this, you will see that it is not getting deployed now. And it says that your the configurations that you are giving doesn't comply with the policies that you have defined, right? And it will not allow that pod to get deployed on your Kubernetes cluster, right? So this is one such example of validating policy, where it is validating a certain configuration for your YAML manifest. Now let's take another example of a mutate kind of an use case, where let's say in an organization you want certain labels to be present on each and every resource of your Kubernetes cluster, right? For example, finance labels, like or accounting labels has to be present, right? So what we have done is there is a policy called add labels, right? So in this policy, it's a very simple policy which is a mutate type of a policy, which actually adds a label called team backend to all my resources which I'm deploying. And the match condition is that it will always apply for a resource of kind pod, service, config map, and secret, right? Now let's go ahead and try to deploy this policy. Right? So I have deployed this policy, and let me get the policies again. So it is deployed, and I have a normal application, which is, let's give it a name as payment app, which is running in a banking namespace, right? And currently it is having a label called payment app, right? In the metadata, label is payment app, right? Now I'll deploy this application, right? So so it is running now. And if I just do k prescribe, so by the way, I'm using an abbreviation here as an alias. So when I describe this pod, and if I just check for the labels that are appeared, you will see that it is having a label called team backend. This was not passed in the YAML manifest, right? But still you will see that it is there, right? So in this way, you can actually mutate certain configurations in your YAML manifest at the time of admission, right? You can add certain configurations, you can change certain configurations, right? So this is one such example of how you can mutate resources on the fly, right? Now let's take another example of generating the configuration or generating a just-in-time configurations whenever such any event happens, right? So for example, let's take an example of a scenario where you want to create certain network policies whenever a new namespace is being created in a Kubernetes cluster, right? And by default, you want to deny all the ingress and egress to that namespace, right? So what we have done is we have created one generate policy, which is called add network policy, right? And what it does typically is, whenever a resource of kind namespace is being created in your Kubernetes cluster, it will generate a network policy for you. You will see that there is a YAML construct for network policy, which denies all the ingress and egress to your namespace, right? Let's apply this policy. So you'll see that the policy is deployed, right? And it is having a background as false. Now, let's try and create some namespace, right? So before that, I'll just do namespace. And currently, there are certain namespaces that are running here, right? Let me create one test namespace. I'll just give a test name to the namespace. Right? So by default, I have not given any network policies to this test namespace, right? But let's see, is there any network policy in this namespace or not? You'll see that there is a one namespace, one network policy called default deny. Now, this part, right? Let's say someone gets a malicious access to your cluster and tries to delete that network policy. Let me do it. So I've deleted this network policy, as you can see, right? It says it is deleted. Let's again try to query this. What do you see? The network policy is still there. It still is created, right? So that's where it is tamper proof. You can't tamper with the generated resources which is being generated via generate policy, right? So these are a couple of examples how you can actually create the configurations or validate or mutate the configurations on a fly, right? So these are some examples. Then there are other examples like image verification, where let's say you have signed your images with some encryption key, and you are using, let's say, AWS signer or notation for signing your images and putting it in the registry for the images. And then you want to actually verify whether these images are coming from the trusted sources or not, right? So that's where you can actually write a policy for the image verification and make sure that whatever images that are getting deployed in your system is verified, right? And similarly, you can attach or attest the SBOMs which are created for your images, and then you can verify those also. Then another type of policy is a cleanup policy, which is pretty much useful in the case when you want to maintain the hygiene of your cluster, right? You want to you want to delete certain stale configurations from your system, or you want to delete certain cron jobs which are, or the background jobs which are already being done, right? So for all those hygiene kind of use cases, you can use cleanup policies and you can actually delete those resources from your cluster, right? Now we have talked a lot about the Kyverno and type of policies that we can write on Kyverno, right? But also let's talk about the validating admission policies that was actually an alternate solution for webhooks that are used for the admission use cases, right? So the admitting policies were actually first released in the version 1.26 of Kubernetes, and now it is in a stable condition with 1.30. So it uses the cell language for actually validating your resources against certain conditions, and it overall reduces the complexity of admission webhooks, which introduce certain latencies to your system, right? So that's where like validating admission policies comes into picture, right? And typically how you can author a validating admission policy. So there are two configurations to it. One is the validating admission policy, which defines the abstract logic of which resource you want to apply it to, and what is the condition that it is going to check, right? Whereas the other configuration is validating admission policy binding, right? So that you can scope those resources to certain conditions. For example, you only want to apply this policy to all those resources which are having a certain labels attached to it, right? So with the binding, you can actually scope that particular resource to a particular policy, and then you can run these validations, right? And the best part is that Kyverno does support these validating admission policies also, right? So you can actually use Kyverno CLI for validating all such use cases. And even there is a quick demo which you can use in the Kyverno playground to play around, to play with the validating admission policies. So typically, all these are fine, but how you will do the reporting for all these use cases, right? So that's where like validating admission policies does support the policy reports. You can even generate the policy reports for the same, and you can visualize it, right? So that's where like you can just you can just create the configurations for the same, and it will actually show you the whole report against your resources which it is getting applied to, right? So with this, I'll rest my case, and I'll ask Avinash to join. Yeah, thank you.
Hi everyone, good to see the full room, and I hope you are taking benefit of the Kubernetes Kyverno thing. I come from Razorpay. Razorpay is one of the payment solutions company. It's like one-stop money movement platform for all the businesses. So if you are either working in a startup or you are thinking of starting your own startup, and if you want to collect money, if you want to pay to your pay salary to your employees, if you want to pay to your vendors, Razorpay is a solution to be. I'll just give a brief idea about the infrastructure that we manage. So we have about, I think, little more than 60 clusters. We have about 3,000 nodes, little more than that, managing 25,000 cores. I think way beyond 100 terabytes of primary memory, 50 petabytes of storage, 70,000 pods on a regular basis. Of course, it's dynamic scaling up and scaling down based on the traffic. And we are using Kyverno. So I'll invite my friend Soji, who works at Razorpay with me. I am heading DevOps and IT functions at Razorpay. So please feel free to reach out to us if you want to know more about how we are using Kyverno or anything else. So over to Soji.
Good evening, folks. My name is Soji. I work as a staff DevOps engineer at Razorpay. So as Avinash mentioned, we are using Kubernetes for running majority of our workloads. More than 95% of our workloads are running in KDS. So it is very important for us to make sure that this infra is secure. And as part of KDS security, we wanted to make sure that there is a policy engine using which we can enforce infra as well as security best practices. So initially, we were using another policy engine, which is also open source, called OPA. However, we faced some challenges due to which we started looking for alternatives. So some of these challenges are listed here. So basically, any rule in OPA needs to be written in a query language called Rego, and Rego comes with its own challenges and complexities. Especially the learning curve for Rego was very high, and debugging policies, especially complex policies, are challenging and time-consuming. So what we have seen is, because of these challenges, we have seen very less adoption within the organization. So one thing that we wanted to make sure is that it's not only DevOps or infra team contributing to these policies, but everyone within the organization is able to write policies very fast. That was not happening. So based on these learnings from OPA, we started looking for an alternative tool, and we outlined certain requirements that this new tool should come with. And they are listed here. So it should be highly scalable, since every request that is going to KTS control plane is intercepted by these admission controllers. It should be highly scalable. Any latency addition or downtime due to these controllers can impact production traffic. So we wanted that to be highly scalable. Also, we should be able to write policies without actually writing any code. Maybe there could be 5% of use cases where we will need to write complex policies. And even in that case, we should be able to write policies in our language of choice. So within Razorpay, we mostly use Python and Golang for automation. So preferably, we wanted to use these two languages whenever we are writing these complex policies. Also, there should be pre-written policies available in open source. So that we can just lift and shift instead of writing these policies from scratch. Also, the community support should be good. So based on these requirements, we started some evaluation in based on whatever policy engines available in open source. And what we found is that Kyverno is satisfying almost all of these requirements. Kyverno is highly scalable. You can scale it horizontally and vertically in many components. You can write rules in YAML, so you don't need to write code for simple policies. And for complex use cases, it provides a service call. So basically, you can write policies in YAML, and from YAML, you can make an external API code, and you can write your policy language in whatever language that you prefer. So based on the response received from that external API call, you can deny or accept request in your policy. Also, community support was very good, so we decided to go with Kyverno, and we implemented that in our production. So how we are leveraging Kyverno within Razorpay? So we have mainly two use cases. One is security, and second one, infra best practices. So we have a lot of rules written for enforcing both of these. And mostly port security policies, you can see we are denying any kind of privilege escalation. We are denying external registries. We are denying host network PIDs, etc. And as infra best practices, we are enforcing CPU memory request and limits. We have enforcement for certain DNS policies, etc. So I would also like to showcase how one use case where we are, Razorpay is using complex policies. So recently, Razorpay started migrating its workload to Graviton as part of cost optimization and taking benefits of lesser latencies Graviton is providing. So while we were migrating, so if you are aware, if you want your application containers to run in both Graviton as well as AMD instances, your image should support multi-arc. So basically, your image manifest should have both ARM64 image as well as AMD64 images. So while we were migrating our existing workloads to multi-arc, we also wanted to make sure that any new application that is getting deployed also follow this multi-arc images. So in order to do that, we have written a policy. So you can see this policy here. So you can see we are making actually an external API code where it is calling v1/check image arc. And this policy, this external API call is implemented in Golang. And based on the result returned from that check image arc API, If it is returning false, then we are denying the request. You can see the Golang implementation of the policy logic here. We are using a package called Crane, and the images which are part of the deployments or stateful set, they will be passed to this endpoint as a list. We are going through each of these image list and then check if it supports both the architectures. If it is not, we are denying the request. So overall, within Razorpay, Kyverno has helped us to enhance the security of our KTS infra. Since the policies are easy to write, we have seen greater adoption. We are also exploring advanced use cases of Kyverno, like image signing and supply chain security. That's it. So in the next slide, Vishal will talk more about how Kyverno can be used more than a policy engine. Over to you, Vishal.
Yeah. So far we have seen how Kyverno can be used to ensure automation and security in a Kubernetes cluster using its different capabilities like validation, generation, and mutation. And to summarize, Kyverno is a very simple to use tool with a large variety of policies which can cover all of the standard use cases. It also does not require any coding experience to begin with, and it is Kubernetes native, which means it works flawlessly with all of your other Kubernetes components. But as you can see in the last point, it is not portable, and that is because of how we started out as a project. So Kyverno started out as a Kubernetes dynamic admission controller, and we kept on adding more features on top of it to fulfill user requirements. And that had a side effect, that is, Kyverno is now very coupled with Kubernetes. And honestly, it should not really be that way, because any of the guarantees and design principles of Kyverno does not really depend on Kubernetes. So to fix that, what we decided to do is... Cancel. Where should I go? Let me find it. Um, yep, thank you. Yeah, so where was it? To fix that, what we decided to do is we decided to take a step back and create a new engine from scratch, which will build on top of all the design features from Kyverno, like simplicity and like no coding requirement, but it will add portability and like more expressive syntax, such as use of cell and James path to it. And we came up with a new engine called Kyverno JSON, which builds on top of the design philosophy of Kyverno and adds more expressive syntax on it. So to understand that better, let's look at some examples. So on your left, you will see a Kyverno cluster policy, and on your right, there is a Kyverno JSON validation policy. They look very similar, but if you look at the match block, you will realize that Kyverno uses the match syntax where you have to specify the resource and kind, but in the validation policy, you have to specify exactly what you'd want to see in the YAML object. So if you want to match a deployment using its YAML, you have to specify the root keys like API version and kind, and whenever the validation policy sees those keys, it will match the resource. And as another example, you can see the difference between validate pattern in Kyverno and Kyverno JSON's assert logic. So the logic plays out here as well, where you have to specify the spec root key in the check block. But you will see there's a special syntax in parentheses, where whenever you put an expression inside a parentheses, that is either evaluated using a James path engine or a cell engine based on what you prefer, and it will be matched, the output of that expression will be matched against the right side value. So it will allow you to write very simple policies, but you can also write very complicated expressions if you want, using cell and James path, and both of the engines are very powerful to write anything. You can express all of your needs in that. Another example you can see is that Kyverno supports this feature called a for each loop, where you can apply your validation expressions on every single element of an array or an object. And to do that in validating policy, we have our special syntax called with, as you can see in the second last line, there's a strictly bracket and a dot, and whatever object you put in that, it will loop over all of them, and all the assertion that comes beyond after it, it will apply to all of the elements in your object. And putting that all together, you will see there is a policy with the match block that is matching all the ECS task definition in AWS. And after that, it will apply to all of the ECS task definition to check that the network mode on those task definition is set to AWS VPC. You can see this policy can be used on in any AWS config. So this is an example of how you can use Kyverno JSON outside of just Kubernetes. Kyverno JSON is a complete tool in itself, but you can also use it to create another tools. And we have done the same. We have created two new tools from Kyverno JSON. One of them is called Chainsaw, and another is an Envoy plugin. Let's go a little deep into that. Using Kyverno JSON engine, we have created a new end-to-end declarative testing tool, which can be used to test any of your Kubernetes controller. And it follows the same design philosophy as Kyverno, where you can just declaratively state what resource you want to create. And you can also assert what the state you want to see in the cluster. So here in the example, in the create block, we are creating a config map, and then we're asserting that the config map is properly created. And it is a very simple syntax, which is very easy to get started with. But it also supports very complicated conditions as well. So for example, let's say you want to have complex cases, like let's just say take a simple case where you want to ensure that the number of replicas is more than 3. Any number more than 3 works. So you can use James path expression to fulfill that condition. And you can also loop over all your containers. Everything that is possible using James path and cell is also possible using Kyverno Chainsaw. And it is very flexible and simple at the same time. The another tool that we created is an external authorization filter for Envoy. So Envoy allows you to delegate all your requests to any external authorization server to make sure that the request is correct before moving forward. So what we did is we used their external authorization API, and we coupled that with Kyverno JSON, and we created this server which will watch on Kyverno JSON policies, and then it will deny or allows those traffic based on the policy content, right? So to look at it, there's an example where we are creating some variables based on the object we receive. We're checking some headers, we're parsing them, and based on the header, based on whether the request is authenticated, we are sending an allow response in this case. You can send whatever response you want, everything you can do. It is a very expressive syntax. You can use all different complicated cell expression in this, and it is very simple as well at the same time. So to summarize, I think we have finally reached the goal of making Kyverno available to outside just Kubernetes. So we have still managed to keep the simplicity and no coding requirement of Kyverno, but we have also added portability to it, and we have provided more freedom for policy author by adding support for cell. And cell is something that Kubernetes is adopting everywhere, so it is good for us as well, because everyone who's going to use Kubernetes and anywhere else, it will learn cell like anyways in the future. So that's good. To conclude, Kyverno is a policy as a code tool which which helps you to automate and to ensure security and automation in your cluster. It has different capabilities like validate, mutate, generate, cleanup. We looked at that in this presentation. You can also create policy reports using Kyverno, and we have this new testing tool called Chainsaw, and now you can use Kyverno on any JSON payload, right? And if you would like to talk to us more about Kyverno or other Kyverno-related project, you can find us at Exhibition Hall 1B. We have a booth going on right now, and we will still have a booth tomorrow in the second half. You'll find us at table number 4. And here's a QR code to our GitHub organization, and you can find our socials, all of our speaker socials in the other QR code. So thank you. If anyone has any questions, you can raise them now. Sure. How do I give you the mic? I don't think we have another mic. So I don't think we have 2 mics, so it will be difficult to coordinate, but let's see. So.
Thank you. So my question is like, is there a cap on the number of policies that we can apply using Kyverno? No. Okay. And one more question, like Soji mentioned that you were exploring you have one tool earlier and there was a problem with debugging policies, and that's why you opted for Kyverno. So how does that solve that problem of debugging?
That was difficult to ramp up on for the newer engineers, while Kyverno is JSON. very regular JSON thing, right? Everybody knows. So that's how Kyverno is helpful. There's no real knowledge transfer that is needed or knowledge ramp up is needed. In case of OPA, there was a custom language that was being used, and that was the main reason. That Rago, everybody had to learn it in order to change or do anything. That was the one of the major reasons.
And for the first question where you asked about number of policies, so there's no limit on number of policies, but you have to make sure that all the policies execute in under 30 seconds, because that's the limit set by Kubernetes for us, right? So if you make any external API calls, you have to ensure that all of the policies can get applied. Otherwise, you will get a context deadline exceeded error. Any other questions?
Hi, my name is Anuj. I didn't catch that part that where you applied a policy and it applies a certain label on the pod. Does it work if a pod already exists and then you create a policy?
Yes, it does work for the existing resources also. So there is a configuration where you can actually say apply it to the existing resources also. So it does work for the existing resource.
Now that raises another question that I want to apply policies on production. I gave a deadline to my team that okay, in 15 days we're going to deploy Kyverno on production. It's mandatory that you guys make your pods policy friendly, but at the same time I don't want to deploy after 15 days and break 5 of the applications. So how to avoid that? Are there any warning systems?
So there's a good question, by the way. So definitely you can actually avoid these conditions by having a policy exceptions, right? So you can even create policy exceptions for certain resources and make sure that those are not failing the overall policies, right? So with the policy exception, you can actually get out of that condition where 5 of your application is not falling into that path, and then once those applications are ready with the configuration changes, you can actually apply those and remove the basically you can automatically resolve those exceptions also. It's a time bound exception which you can create.
Also, you can
Okay.
have policies in audit.
Yep.
Also, there are 2 modes you can set your policies in.
There is a audit mode?
Yeah, that's audit and enforce. So enforce is when you want, strict application of policies.
And where do you
Yeah.
get all this audit warnings or maybe errors?
Policy report. So whatever. So Kyverno produces a policy report, and that's a Kubernetes CRD that will be present in your cluster. So all your audited resources that were failing some policy will be visible in this policy report, so you can analyze your cluster accordingly.
And even there is an open source project which is called Policy Reporter, where it's a dashboard where you can see all the resources which are actually violating these policies, and you can fix it.
That's helpful. Thank you.
Maybe we can take these questions.
I think
here
we're
now.
running out of time. We can take these questions after. We'll be around here. So I think they have announced it.
There's a break
Our
now.
break was 5:15. 5:25 is when our ends.
So we can all come here.
I mean, we'll be here. So thank you so much for joining.
Thank you so much. We can take the
Yeah.
other questions.
If you have any
offline.
questions, you can reach out to us directly. We'll be here.